Hey everyone. Yeah, super glad to be here. This has been a ton of fun so far. And I can control the slides here. Perfect. Yeah. Like I was said, I've worked in security for almost a decade now. Um, about over half of that has been focused on either being part of or building lean, efficient, and modern security programs. It's what led me to build a lot of tools like I'll talk about today, PII Detective. Um, but there was a story behind PI Detective and a lot of insights learned along the way, which is what I'll talk about here. Yeah, at a high level, PI Detective is a tool to basically detect and mitigate and protect PII in data lakes such as Snowflake and BigQuery. And so for this talk, we're going to go through what is dynamic data masking, a really cool feature in these data lakes that I think is heavily underutilized. We're going to talk about the problem of why I think it's underutilized, and then why AI unlocks some of the potential that was previously impossible, that we couldn't do before at scale. And then we'll talk about PI Detective, which is kind of the tool that I built that kind of packages all together. Cool. Okay. Dynamic data masking is a tool that's like common in BigQuery, Snowflake, Databricks, and so forth. At a core level, it's column level RBAC controls. And you could basically say like, hey, like everyone can read these tables, but these specific columns, only privileged users can access it. And the way it works is you go into Snowflake and I guess y'all can't see my mouse, but I'm kind of pointing at like the little masking policies on the side there. And you say, okay, we're going to create these two roles. One is the PI access role and one is the normal user or analyst role. And you can obviously create many more, but for this example, we'll just have these two. And so on the table side, you go through all the tables and you say, okay, these are the sensitive columns. We're going to apply the masking policies to these columns. And now when privileged users run a query, they can see all the raw data. But when a normal user runs a query, they still get the same table, but now these sensitive columns are encrypted. I think it's really notable here is that masking occurs at query time. And so you don't need to deduplicate data at all. Folks can run the same exact query. And so what's really cool is that, let's say a normal user runs a query and it returns mass data and they go, oh, you know what, for this specific use case, I need to see the raw data. They can get access. They can contact security team or IT team or whoever, get access to those roles and then run the same exact query and get the raw data. And so from a user experience perspective, it's really, really fluid. You don't need to encrypt it. You could do custom masking such as like, hey, like the last couple of characters, let's just do star instead of the actual raw character. But for me, I would suggest just using encryption. One is it's very standardized across different column types. You don't have to think about like, oh, what type of data am I masking? You just have to mask it. And then in addition, encryption uses the same seed. So although the users can't see the raw data, they can still do advanced analytics such as cross-table joins. And so like in this case with like players tables, the players team and games tables, you can say something like, okay, I want to know the distribution of MVP awards across all players who earned at least one. And so you could do a join based off of MVP name and player name, and then filter out all those that don't have and do a group by count essentially. And you can still do that without actually seeing the name of the player itself. And so why is this underutilized? And so actually, if you go back here, we have these masking policies and we have all the columns that are tagged, but as you see, like we have 3 tables and 12 column names. And so this is a very, very simple example, but the issue with data lakes is that they're built to handle tons and tons of data. It's literally built to just dump as much data as possible and you just query off of it. And so it's very hard to figure out where PI is being stored. And all these services, they offer tools and services like in GCP, for example, of like, hey, like we'll scan your data for you and tell you which ones are PII. But the issue is that their strategy of like the strategy they have to do is to basically run hundreds of regexes on all of your data, which is super, super expensive, super, super time consuming, to the point where even like GCP like has this warning banner. Like this is the first thing you see when you visit that page where it's like, hey, costs could become very, very high. And they don't do a good job. I can tell you, they don't do a good job of telling you how high it's going to be. It's only until after you run it where you realize, like, oh man, that's a ton of money down the drain. And even then, they're not foolproof. At the end of the day, they're just basic regexes. And so I know, like, when I ran this in the past, there'd be cases where, like, it would find driver license IDs, even though it had nothing to do with driver licenses. And so it's, like, very expensive, very slow, and didn't even work that well. And so why does AI unlock this? And so AI enables us to automate intelligence. And that's something that couldn't have been done before. And a really good way of showcasing this is if we go back here, and if I told y'all, imagine like you just saw these 3 tables without the locks in there, just like the tables. And I said, hey, there's a table called players, and the columns include like player ID, name, and age. Do you think name is PII? And then you probably say like, yeah, it's the players, there's age next to it. Yeah, that would make sense that like, this is most likely someone's maybe like first and last name as a string. And then you look at the team table, okay, this team, there's a column also called name. It's the same column name, which is name, but the table name is now team. And so, oh, this probably isn't a person. This is probably a team name, such as like Golden State Warriors or something. But how do you automate that? Like that's intuition that you can't achieve with basic like if else statements. And so I think that intuition is what like AI can really unlock, where you can give this metadata to an LLM and you can say like, hey, this is the data set is NBA, the table is players, and the column it's name. And so LLM is able to understand that, oh, this is most likely a player's name, and can print that out in JSON. And now you have this really powerful tool that allows you to do this at scale, right? Like you can have, I think Caleb was talking about this in the intro, but like you can scale this out as you could have one for every single table in Snowflake. And in addition to, it's like you could also like fine tune these models to match your environment. There's a lot of ways this can grow. And so, with this kind of solution, now we have this case where you don't need to run hundreds of regexes. In fact, you don't even need to analyze the raw data at all. All you need is the metadata, which is safe, no PII metadata. You could send that to an LLM, and you can scan thousands of tables for like $5, which is pretty cool. See you next slide. And so that's what PII Detective is. And so PII Detective is a tool which is basically, it goes through all of your, let's say, BigQuery tables. And for each one, it'll determine, hey, these are PII, and it'll give you confidence score in the type of PII it thinks it is. And it presents the security analyst a web UI, sort of thing that's similar to like Wiz, how Wiz scans your cloud environment and escalates things that are sensitive. This will also escalate columns that it thinks are PII, and the analyst can go into the UI and review it and click accept or deny, which is where like human in the loop comes in. And when they click accept, it will add the masking policy to your data lake. And so now you essentially have this like almost like hundreds of analysts going through every single table and escalating which one's a PI for you. And all the human has to do is review it and approve or deny. And everything else works downstream. And so a video here. I'm not sure if I'm able to, will this work? Okay, and can I pause it? Because it goes kind of quick. All right, well, what's happening here is it scanned the tables. When they're clicking accept, it goes into backend and does it. And now, okay, this is going really fast. But basically, on the user side, you can see how the user just ran the same exact query, but because, thank you for running that again. But because the dynamic data masking policy was applied, they see the encrypted data. And what's cool about this UI too is that if you get a column, which you're unsure if it's maybe it was low confidence and you're unsure and you want to double check to see if it's actually PII. Can you run that more time? Actually, it's kind of a good point. Um, yeah. So it's searching it. It's finding. Click the first one. This is definitely PII. Look at the second one. You could click fetch sample data and it'll highlight which column is the one in question, so that you can quickly make a decision. Okay. You could do next slide now. Let me get to it. Yep. Thank you. Okay, and so the key takeaway I think I really want to drive home with this presentation is that one, automating intelligence is super, super easy. And like this code is literally like the meat and potatoes of PI Detective, where you have a very basic, simple system prompt where it's like, hey, could you please identify PII? Like we're going to give you metadata, please identify PII. And it's literally like a for loop going through all the tables and just giving it to OpenAI and saving the response in a database. And so the hardest part of this project was actually the front end, because I'm not a front end developer. And so I Next.js, and I had to learn like, okay, like how to manage state and web UIs and stuff. But like the breakthrough part was actually the simplest. And I think this is like the best metaphor for like that classic meme of like, you can just build things. Like you don't need a massive framework or system or anything. You literally just need like a very basic Python script and some OpenAI credits. And like speaking of price too, like it's super cheap already. It's only going to get cheaper. These, it's insane. Like I think I built this like a few months ago, and I think now prices have gone substantially down. So I think even $5 might be a little on the upper end. And I also want to, like, I know we talked about this in chat and folks that talked about it in like various calls, but like having human in the loop, I think is key to having these things be production ready, right? We're talking about like, oh, like everyone's like, oh, these agents are where like they're great. And then they start to hallucinate and we don't want it to go haywire. And I think even though I could have written a Python script that just does the tagging and everything for us, I think having that web UI element with some human loop verification is essential. And I think is what I think is really unlocking, or I guess it's like not having that human loop is what's restricting security teams from really implementing AI into their operations. And that is it. This project is open source. I would love if folks gave it a try and contributed to it, and maybe improve some of the front end. Because like I said, that a front end developer. So that was a fun weekend with Cursor and MBO. But yeah, thanks for having me.
Excellent. And the live demo that went off flawlessly.
I recorded it. It doesn't count as a live demo.
Doesn't matter. It works well. This isn't a question in the chat, but I'll phrase it as a question. Why didn't you decide to go and vibe code the front end?
Oh, I mean, I try. I used V0 very heavily, as well as Cursor. This was like a few months ago, so it was like before Claude 3.7 came out, and so I would like to blame that. But honestly, this was more of just like, hey, this is something I want it to be good enough to have like a solid UI. I think in Insight, what I would have done is have made it into a CLI interface similar to Claude Code. Probably the easier than building a bunch of web UI.
Makes sense. Another question we had come in. What types of data lakes does the PII Detective support right now?
Yeah, it supports BigQuery and Snowflake. I know Databricks has the ability to do dynamic data masking. I just haven't messed around with it. So if any of you are Databricks customers and want to try to incorporate this into Databricks, very open to contributions.
All right. And all the models, which ones to use and which ones perform the best?
Yeah. So at the time, OpenAI was definitely the clear winner, and I think a lot of the setback was because, again, at the time, this was before they released JSON output. Like you could like enforce JSON output, and so it was the best at you putting in the system prompt. You must return JSON, and it actually reliably does it. Now, though, they all do it. Everyone does that. And so I haven't done a decent analysis about models, but I will say I'm a little biased towards Perplexity. I know the Sonar PI is really cool. It's definitely a biased opinion, but I think y'all should check that out.
So you've said, and some folks in the chat have said, human in the loop good. What
Humility.
what would it take for you, for PI Detective specifically, to decide you didn't need human anymore? What is that? What is that tipping point?
Yeah, that's a good question. I think it needs to be, I can see how maybe something like PI Detective, where maybe the impact might be, if it gets it wrong or goes haywire, the impact might be some analysts can't get the data they need immediately. There might be some business operations slow down. It's nothing customer facing. Um, and so like something with PI Detective, like I could see where we get really confident in its abilities. I think a really good example of that is like in my experience with PI Detective, like anything PI Detective claims as high was almost certainly PII, to the point where like, oh, maybe if its confidence is super high, it's able to explain its reasoning. Like, okay, let's have that automatically apply. Um, I think it's going to be a long time before we do things like quarantining a laptop automatically without human in the loop, or reaching out to customer communications about an impact, like something like that, where I think it's going to be very, very based off of the impact if something goes wrong. I think PI Detective, though, given the impact is fairly low, I think has an opportunity to become more self-sustainable.
All right. Thank you so much for coming on and showing us how it works.
Yeah, thanks for having me.
All right.